everyone. Hope all of you are doing well. Today we are going to discuss the continuation of NCERT textbook exercises from the chapter Electricity of grade 10. In the previous video we have discussed till question number 5. If you have not watched till part 4, please watch it before going ahead with part 5. Now we can move to the first question. Page number 221 and question number 6. A copper wire has a diameter 0.5 mm and resistivity of 1.6 into 10 raised to minus 8 ohm meter. What will be the length of this wire to make its resistance 10 ohm? How much does the resistance change if the diameter is doubled? Here the diameter of the wire, resistivity and resistance are given, and we have to find the length of the wire in the first case. And one more question is there, that is, if the diameter is doubled, we have to calculate the resistance. We know that the area of cross section of the wire A is equal to pi r square. Here the diameter is given, therefore we can write it as A is equal to pi into d by 2 the whole square. And the diameter is given as 0.5 mm, so that we can convert into meters, that is 0.0005 meters, and resistance is given as 10 ohm. Here the resistivity is also given, that is rho equal to 1.6 into 10 raised to minus 8 ohm meter. In order to calculate the length of the wire, we can use the equation R is equal to rho into L by A, and when we rearrange it, L will be equal to RA by rho. Here A is equal to pi into d by 2 the whole square. So directly we can substitute here. Then we will get it as 10 into 3.14 into 0.005 by 2 the whole square divided by 1.6 into 10 raised to minus 8. That is equal to 10 into 3.14 into 25 divided by 4 into 1.6. So that value is 1.22.72 meters. That is, the length of the wire is equal to 122.72 meters. Okay, now we can move to the second part of the question. That means if the diameter is doubled, what will be the new diameter? That will be equal to 2 into 0.5. Right, that will be 1 millimeter, that we can convert into meters, that is 0.001 meters or 10 raised to minus 3 meters. So what will be the value of new resistance? So the same equation we can use for this also, right? So R is equal to rho into L by A. Here R dash will be equal to rho into L by A. Now we can substitute the values of rho, L and A. That is equal to 1.6 into 10 raised to minus 8 into 122.72 divided by pi into half into 10 raised to minus 3 the whole square. So that value is 1.6 into 10 raised to minus 8 into 122.72 into 4 divided by 3.14 into 10 raised to minus 6. The answer is found to be 250.2 into 10 raised to minus 2, that is 2.5 ohm. Therefore, the length of the wire is 122.7 meter and new resistance is 2.5 ohm. Now we can move to question number 7. The values of current I flowing in a given resistor for the corresponding values of potential difference V across the resistor are given below. That is, current I in amperes 0.5, 1, 2, 3, 4, and the corresponding potential difference is V in volts, that is 1.6, 3.4, 6.7, 10.2 and 13.2. Plot a graph between V and I and calculate the resistance of that resistor. Here the values of V and I are given. By using the values we have to draw the graph, and from the graph we can calculate the resistance. The graph between voltage and current is called IV characteristics. Here the voltage is taken along x-axis and current is taken along y-axis. The values of current for different values of voltages are as shown in the table. Here for 1.6 volt the corresponding current is 0.5. In the same way we have for 3.4 volt it is 1, for 6.7 volt it is 2, then 10.2 volt is 3, and for 13.2 volt the current is 4. Now we can draw the IV characteristics as shown in the diagram. Here the voltage is taken along x-axis and current along y-axis, and we have to select an appropriate scale in x-axis and y-axis, so that here the voltage varies from 1.6 to 13.2, so it will be better to select 2468 like that, and along y-axis the current is varying from 0.5 to 4, so that we can select 1, 2, 3, 4 like that. Any scale we can select, but we should include all the values there. For marking the first point, we have to take 1.6 along x-axis and 0.5 along y-axis. Then we will get a point like that, 3.4 and 1. The corresponding readings we will mark, and we will get a straight line passing through the origin. For calculating the resistance from the graph, we can select a slope here. Here we can see that ABC, that is a slope here, and from the slope, that is y by x, we can calculate. That will be equal to BC divided by AC. Then we will get 1 by R, that is 2 by 6.8. So that R will be the reciprocal of slope, that is 6.8 by 2, that will be equal to 3.4 ohm. That is, the resistance of the resistor is 3.4 ohm. Now we can move to question number 8. The question is, when a 12 volt battery is connected across an unknown resistor, there is a current of 2.5 milliampere in the circuit. Find the value of the resistance of the resistor. Here we have to calculate the resistance of the resistor. So which equation can be used here? We can use Ohm's law, right? Because the potential difference and the current in the circuit is given here. We have to calculate R. So that R will be equal to V by I. That is, from Ohm's law we have V is equal to IR. Therefore, R will be equal to V by I. Here, potential difference V equal to 12 volt. Current in the circuit I is equal to 2.5 milliamperes. So, that will be equal to 2.5 into 10 raised to minus 3 amperes. So, for getting resistance, we can substitute the values. That is, R equal to 12 divided by 2.5 into 10 raised to minus 3. So, that will be equal to 4.8 into 10 raised to 3 ohm. That is 4.8 kilo ohm. Therefore, the resistance of the resistor is 4.8 kilo ohm. Now we can move to question number 9. The question is, a battery of 9 volt is connected in series with resistors of 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.5 ohm and 12 ohm respectively. How much current would flow through the 12 ohm resistor? Here in the case of series combination of resistors, we have to calculate the current flowing through 12 ohm resistor, right? Here it is given that the resistors are connected in series. That means there will be no current division in the circuit. Therefore, current flowing through the components will be the same. So, we can find out the value of current from Ohm's law, that is V is equal to IR. From this, we will get the value of I as I is equal to V by R, where R is the equivalent resistance of the resistances of all resistors. Here it is connected in series, therefore the sum of the resistors will give the value, that is R equal to R1 plus R2 plus etc. Where R is equal to 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12, that is equal to 13.4 ohm, and the potential difference is given as V is equal to 9 volt. Therefore, I is equal to 9 divided by 13.4, that is equal to 0.671 amperes. Therefore, the current that would flow through the 12 ohm resistor is 0.671 amperes. Now we can conclude our video. If you like my videos, please like, share and subscribe. Thanks for watching.